Assalamu alaikum. Hello dear student, how are you all? Today we will learn theorem 4 based on Pythagoras theorem. We already know the theorem 3. Okay, so theorem 3 was related to the obtuse angle and theorem 4 is related to the acute angle triangle. So let's start. Theorem 4. In any triangle, the area of the square drawn on the opposite side of an acute angle is equal to the square drawn on the other two sides diminished by twice the area of rectangle included by any one of the other sides and orthogonal projection of the other side on that side. This theorem is also we can divide in three parts. First part is the area of the square drawn on the opposite side of an acute angle in triangle ABC. Here C is acute angle, so opposite side of this acute angle is AB. So if we draw a square taking this side AB, so area will be AB square. Okay, so acute angle, here is the first part, is equal to the square drawn on the other two sides, equal to the square on the other two sides, this side and this side, which will be AC and BC. So this is the second part, diminished by twice the area of rectangle included by any one of the other sides. Okay, if we take the other side BC, then we need to make a rectangle taking side BC and the orthogonal projection of the other side on that side. Okay, the orthogonal projection of the other side AC will be, if we draw a perpendicular on BC, the orthogonal projection will be CD from here to here. CD is the orthogonal projection of AC side. Okay, so we need to make a rectangle where the two sides of the rectangle will be BC side and the orthogonal projection of the AC side. Okay, here is the part 3. Okay, so a special nomination in triangle ABC, ABC triangle, ACB is the acute angle and the opposite side of the acute angle is AB. Okay, the other two sides are AC and BC. Okay, suppose AD is perpendicular on the side BC, AD is the perpendicular on the side BC, left sided figure below, and the right side the extended of BC. If we extend this side BC, okay, up to D, and we need to draw a perpendicular on BD, will be AD. Okay, so CD is the orthogonal projection of this side AC, so CD is the orthogonal projection on this side AC in that case of both triangle. Okay, in the case of both triangle, here orthogonal projection will be from here to here. Okay, CD will be the orthogonal projection on of the side AC. Okay, so it is to be proved that AB square, which is the opposite side of the C acute angle C, AB square equal to AC square this side plus BC square this side minus which will be diminished. Okay, 2 into BC into CD. BC is the other side and CD is the orthogonal projection of the other side. Okay, so it is to be noted that here the perpendicular is drawn from A to C. We draw a perpendicular from A to BC, but similarly the theorem can be proved by drawing a perpendicular from point B to A. If we draw a perpendicular from here to here, we can also prove this theorem. Okay, so let's prove. It's also a easy theorem like theorem C. So proof at first, in triangle ADB, which triangle? This triangle ADB triangle, here ADB, okay, and ADB is right angle. Here ADB is this angle is the right angle. So according to the theorem of Pythagoras, we can say, we know that Pythagoras, in the theorem Pythagoras, hypotenuse square equal to sum of the square of other two side. Okay, so AB square equal perpendicular square AD square and plus base square BD square, equation 1. Okay, in the left sided figure above, this this figure above, BD equal BC minus CD. Here BD side equal to what? BC total from here to here, BC minus CD. Okay, so we can write here BD equal, so therefore we can write BD square, this here BD square equal BC minus CD, BC minus CD whole square. So we know that A minus B whole square equal to A square plus B square minus 2 into BC into CD. So here BC minus CD whole square equal to BC square plus CD square minus 2 into BC into CD. Okay, in the right sided figure above, this figure, BD equal CD minus BC, BD here BD equal CD minus BC. Okay, CD minus BC. Right, BD square equal CD minus BC whole square, same, A minus B whole square equal A square plus B square minus 2 into BC into CD. So here CD minus BC whole square equal CD square plus BC square, this BC square minus 2 into CD into BC. So therefore we can write in both figure BD square equal BC square plus CD square minus 2 into BC into CD. This BD square equal BC square plus CD square minus 2 into BC into CD, and here BD square equal BC square plus CD square minus 2 into BC into CD, equation 2. Okay, so now from equation 1 and 2 we get, from equation 1 and 2 we get AB square equal to AD square plus here BD square equal to BC square plus CD square minus 2 into BC into CD. Okay, or AB square equal to AD square plus CD square plus BC square minus 2 into BC into CD. Okay, equation 3. Again, in triangle ADC, which triangle? ADC triangle, this triangle, and ADC, this triangle, right angle triangle, and ADC is a right angle. Here this angle is right angle, here this angle is ADC to ADC is right angle. So we can write according to the theorem of Pythagoras, okay, AC square, which is hypotenuse square, equal to AD square which is perpendicular square plus CD square which is base square. Okay, equation 4. So combining equation 3 and 4, we can write here AB square equal to instead of AD square plus CD square, we can write AC square plus BC square minus 2 into BC into CD. Thus proved. Okay, thank you very much.